We want to evaluate the indefinite integral or determine the antiderivative. When our integrand contains powers of sines and powers of cosines, the trig function with the odd power or odd exponent indicates our strategy. Notice our integrand contains sine cubed x, so the power on the sine function is odd, and it also contains cosine to the sixth x, where the power on the cosine function is even. So because the power on the sine function is odd, we're going to save one sine factor and convert the remaining factors to cosines. The reason we'll do this is we'll let u equal cosine x, and therefore differential u is equal to negative sine x dx. So this is the reason why we need this extra factor of sine x. And while we're here, just to review, if the power of the cosine function was odd, we would save one factor of cosine and convert the remaining factors to sines, where u would be equal to sine x and differential u would be equal to cosine x dx. But again, in our case, since we have an odd power on the sine function, we'll save one factor of sine and convert the remaining factors of sine to cosine. So to get started, let's go ahead and rewrite this as the integral. We'll write sine cubed x as sine squared x. We'll write the extra factor of sine x next to dx. So we still have cosine to the sixth x. And then the extra factor of sine x that we're saving is here, dx. Now again, the reason we're doing this is we're going to let u be equal to cosine x. Therefore, differential u would be equal to negative sine x dx. Let's go ahead and rewrite this second equation here as negative du equals sine x dx. Now if we take a look at what we have now, using u equals cosine x, we could substitute u to the sixth for cosine to the sixth x. And we could also substitute negative du for sine x dx. Notice how this leaves us with this extra factor of sine squared x, which we'll write in terms of cosine and then write in terms of u. So we can use the identity sine squared x plus cosine squared x equals 1, or more specifically, sine squared x equals 1 minus cosine squared x. So now we'll write this as the integral of, again, sine squared x is being replaced with 1 minus cosine squared x, and then times cosine to the sixth x times sine x dx. And now we should be able to write this in terms of u. Since u is equal to cosine x, here we'll have 1 minus u squared, here we'll have u to the sixth, and then sine x dx is equal to negative du. So we'll have the integral of the quantity 1 minus u squared times u to the sixth times negative du. Let's factor the negative out, and then we'll have differential u here. Next, we'll distribute the u to the sixth, so we'll have negative the integral of u to the sixth minus u to the eighth. And now we can finally integrate in terms of u, and then perform substitution for u to find our final antiderivative. So using the power rule of integration, we're going to have negative and then u to the seventh divided by 7 minus u to the ninth divided by 9, and then plus c. And now we'll write this in terms of x. Notice how this first term would be negative 1/7 u to the seventh, and the second term would actually be plus 1/9 u to the ninth. So let's write this as 1/9 cosine to the ninth x minus 1/7 cosine to the seventh x plus c. This would be our antiderivative. I hope you found this helpful.